Okay, part F. So this question is worth 6 marks. It's the last part of the question. Obviously, it's going to be challenging. But we say consider the function g of x equals this. So now x cubed minus 3cx plus d. So it was 2 in the previous part. It's now become d. Well, that was actually back to the original function in part A. Find all the conditions on C and D such that the graph of y equals g of x has exactly one x-intercept, explaining your reasoning. Okay, so let's go back to our 3 situations. C is less than 0, C is equal to 0, and C is greater than 0. This is our three situations for, or our 3 conditions is the better word, our 3 conditions on C, right? Less than 0, I have something that looks like this. C equals 0, I have something that looks like this. And C is greater than 0, I have something that looks like this. The D just decides how much up or down these graphs are transformed or translated. So if C is less than 0, no matter what the D is, no matter how much I move it up or down, obviously this goes on to infinity and negative infinity. So no matter how much I move it up and down, this graph will always have one x-intercept. This is the graph that has no turning points, and it doesn't have this stationary point like this guy does here. So this guy, no matter what happens, if C is less than 0, no matter what D is, even if D is 1,000,000 or negative 1,000,000, this guy will have one x-intercept. So that's the first one. That's the easiest. Well, these two are both similarly easy. If C is equal to 0, for the same reasons, this guy is only going to have one x-intercept. You can see it as I move up and down. The only place where it's a little bit suspicious is at 0, but because it doesn't turn, it will only have this one x-intercept at 0. Everywhere else, look, he has one x-intercept there. No matter where I move this, he's only got one x-intercept. Fine. Now this guy is a little bit more he's a little bit more tricky, because let me just remove these two. As I move him up and down, what happens? So here he's only got one x-intercept. Obviously, when I say x-intercept, you're looking at where it crosses the x-axis. So just keep an eye on where this graph crosses the x-axis. Here, it's crossing the x-axis once. Once. Now, when this happens, it's twice. And when this happens, it's 3 times. But we only want the once. So in order for it to be once, this maximum and minimum have to both be above the x-axis, like this, or below the x-axis, like this, because you have a similar situation here where only one x-intercept. So once, twice, 3, 2, 1. So when C is greater than 0, either both the max and the min are above 0, or the max and the min are below 0. That's the key to the question. The max point and the min point I've written here, guys. I've deduced it using the previous part. If you remember the previous part of the question, the max was at minus root c 2c to the 3 over 2 plus 2, and root c minus 2c to the 3 over 2 plus 2. The 2, the reason that the max and the min are the exact same with the d and the 2 changed is because the d is just a constant, so all it's doing is deciding how far up or down this graph is translated. When you get the first derivative, the d disappears anyway, and then when you find you'll find the same negative root c and root c, and when you sub it in, you'll get the exact same thing, except instead of plus 2 at the end, you'll have plus d. So the max and the min are these. Okay, so first condition, if c is less than or equal to 0, and it says explaining your reasoning. Now the graphs certainly can help to explain the reasoning, but even if you don't have the graphs, you can say if c is less than or equal to 0, then no turning points, hence one x-axis, let me write that again, x-axis intercept. There we go. If c is greater than 0, sorry, I should say then one x-axis intercept if both, let's say the y coordinate, both y coordinates for max and min are the same. Okay, so if the max and the min are positive, we'd have one x-intercept. If the max and the min are negative, we'd have one x-intercept. So both positive, then that means if they are both positive, then this guy has to be bigger than 0. Let's write this down to the max. Let's write this both positive. Both positive. That means 2c to the 3 over 2 plus d is greater than 0. Which means d has to be greater than, let's just write it in terms of d. D has to be greater than negative 2c to the 3 over 2. And both, sorry, this is just the maximum. This is the max. So max is this. The min, negative 2c to the 3 over 2 plus d has to be bigger than 0, which means d has to be bigger than positive this, 2 times c to the 3 over 2. So bear in mind, guys, c is in this, for this condition, c is positive anyway. So d has to be bigger than negative 2c to the 3 over 2, and d has to be bigger than 2c to the 3 over 2. So obviously, if I didn't even need to calculate the positive one, because obviously if the minimum one is positive, if the minimum one is above the x-axis, then if the minimum is above the x-axis, then I'm going to have only one root. Or if the maximum is below the x-axis, so I should have just gone with that, to be honest. But anyway, it's fine. Both negative, then let's just do the max has to be less than 0. So my max is 2c to the 3 over 2 plus d has to be less than 0, which means d has to be less than negative 2c to the 3 over 2. Okay, therefore, all the conditions are either c is less than or equal to 0. That's the first one. If that's true, we're good. We've won an x-intercept. Or or if c is greater than 0. So let me write this properly. C is less than or equal to 0, or if c is greater than 0, d is greater than 2c to the 3 over 2, or d is less than negative 2c to the 3 over 2. So that's, just to be clear, that's one. That's one. C is less than 0, or if c is greater than 0, this d is greater than this, or d is less than this. Okay, hope that makes sense, guys. Obviously, as I said, yeah, that's a difficult question, but as I said as well, it's not. It's manageable. Hopefully, it makes sense. Okay, see you for the next question.